Hello, my name is Steve Bowler, and in this video we're going to be taking a closer look at routing policy. Specifically, within routing policies, I'm going to show you how to set up a basic routing policy on a Juniper router. So in this example, we're going to have two routers, router 1 and router 2. We're going to connect these routers together using logical tunnel interfaces. And so these two routers are going to be logical systems within a single physical Juniper router. So if you're not familiar with logical systems or how to set those up, you can look at my logical systems videos to learn how to do that. Also, in this video, what I'm going to do is show you or explain to you some of the basics of routing policies. So routing policies on a Juniper are similar to what route maps are on Cisco devices. And if you're familiar with the Cisco IOS and how route maps work, you know then that you can manipulate a lot of routing protocol rules and a lot of routing options with route maps. So what we're going to see in the Juniper devices, what routing policies allow us to do is they allow us to control routing information based on the routing protocols, and this can be used in the routing and forwarding tables. So what we're going to see is that routing policies allow us to manipulate things such as the route preference or the next hop. They will allow us also to put tags on routes and a lot of other options. So what we're going to do in this video, we're going to lay a solid foundation on the basics of routing policy. We're going to show you how to set up routing policy, and what better of a protocol to show you this than Border Gateway Protocol, or BGP. So in this lab we're going to have BGP. Router 1 is going to be in BGP Autonomous System 100, and router 2 is going to be in BGP Autonomous System 200. So I'm going to set this lab up from the ground up, so everything from the interfaces to BGP, and then we're going to show you how we are going to export our directly connected interfaces on router 2 into BGP, and also export our directly connected interfaces on R1 into BGP. And we're going to do this with a routing policy. And then in the next part of the lab, I'm going to show you how to use the import routing policy on R1. So we're going to import a routing policy based on router 2's subnets that it's sending us. And we're going to manipulate some of these networks, like the 2 network, the 22 network, and the 222 network. We're going to use a routing policy to manipulate all of these routes differently. So this is going to be a really cool lab to show you some cool things you can do with routing policies on a Juniper router. And if you're familiar with a Juniper firewall filter, then we're going to see that a routing policy is created in the same steps. So we have 4 main things that we have to do to create a basic routing policy. The first one is to name the routing policy. The second option we have is going to be to create different terms within the routing policy. And then each term we have things that we need to match, or what we're going to call, or what we're going to use from. We're going to use the from statement to do that, and then we're going to have our actions to take once we have a match. And our action is going to be specified in the then statement. So 4 key things that we have to do. We have to name it, create our terms, and then inside our terms we have 2 more things. We have to set our match statements, and then our actions, our from and thens. So I'm going to show you how to do all of this. And let's go ahead and get started. So I'm going to go ahead and try to fly through this pretty quickly, how to set up. I'm going to set up the let me explain our network diagram again. We have R1 and R2. The interface between them is the logical tunnel on the 12 network. R1 is going to be logical tunnel .12. R2 is going to be logical tunnel 21. We have a loopback 0 with a logical interface of .1 on R1, with the 1 network, the 11 network, and the 111 network. And then on R2 we have the loopback 0.2 with the 2 network, the 22, and the 222 network. Again, R1 is in BGP Autonomous System 100. R2 is in BGP Autonomous System 200. And we have here at the top right, we have the statement that says all LTs, our logical tunnels, are logical tunnel -120. In this case, for router 1, it's going to be LT120.12, and then for router 2 is going to be LT-120.21. So let's go ahead and get all of this configured first. We're going to do the command set logical systems R1, and then again the interface we're going to use is LT120.12, or we can also specify this with unit 12. Family is going to be inet with the address of 12.12.12.1. We're going to put in our peer unit statement. It's going to be 21. Again, that's router 2's logical tunnel. And then our encapsulation is going to be Ethernet. So again, if you're not familiar with the basics, everything I'm doing now is I show you how to do this and explain it in a lot of detail in the logical systems labs. So go ahead and watch those before you watch this, because it'll help you gain all the knowledge you need to do what I'm doing right now. So also I'm going to set up my loopback. So loopback 0.1 on R1. Again, I can do that by just doing unit 1, or I could do LO 0.1 like this. Family inet address 1.1.1.1/24. Then we're going to have the 11 network. And then the 111 network. So all these networks I'm just going to add into BGP with a simple routing policy. I'm going to show you how to do this. That's going to be our introduction into the routing policies, just to show you how to create a simple export statement to add networks to your BGP connection. So now that we have the interfaces created, let's go ahead and do everything we need to do on this router. So set logical systems R1, protocols BGP, and then our group. So if you're not familiar with BGP on a Juniper device, how to set it up, you can go ahead and watch my Juniper or my BGP Lab 1, where I go over how to set up an external BGP relationship between two routers. So this group, I'm just going to call it 2R2. Again, the type is going to be external BGP, where you're going to put in the peer autonomous system is going to be 200 for router 2. Oops, let's see. Yeah, that's right. And our neighbor statement, so 12.12.12.2, and that should be it for now. So let's go ahead and commit this. Oh, let's see. Oh, whoops, we forgot to define our local autonomous system number. And the way we're going to do this is under the logical system for R1. It's not under protocols, it's actually under the routing options. And then we're going to put in autonomous system, the local autonomous system for R1, which is 100. So let's go ahead and try to commit this again. And we have an error. It says address 12.12.12.1/32 cannot have just a host address. Okay, so looks like I forgot to put in my subnet mask. Let's go ahead and do this then. Let's go ahead and delete this statement, and then what we'll do is put in on my subnet the correct subnet mask, and then we'll re-add this. Let's go ahead and commit that, and we should be good. So router 1 is done now. Let's go ahead and do the logical system R2. Let's start with the interfaces. Set logical systems R2, interfaces LT. Again, this is 120. The unit is going to be 21. Family INET address 12.12.12.2/24. Then our peer unit statement is going to be 12, and our encapsulation type is going to be Ethernet. So now we have the connection between R1 and R2 set up. Let's go ahead and set logical systems R2 interfaces loopback 0 for unit 2. We're going to put in our subnets on our loopback, which are the 2 network, the 22 network, and then also the 222 network. Okay, so that should be it. We have our loopback and our logical tunnel on R2 defined. Let's go ahead and set up BGP on R2. So we'll do the command set logical systems R2 protocols BGP, and then our group is going to be called for R2. We're going to name our group, name is going to be 2R1, and then our type is going to be external, so we're running eBGP. Also the peer autonomous system is going to be 100 for R1, and our neighbor statement is going to be 12.12.12.1. Our last statement we need to get BGP running is set protocols BGP, set logical systems R2, routing options, autonomous system, and then our local autonomous system on R2, which is going to be 200. Let's go ahead and commit this. And now if I go back, if I do a show BGP summary, let's do this. Show BGP summary, logical system R1. So we're doing a show BGP summary just as though we were sitting on R1. And we can see that we have a BGP neighbor relationship formed, and that it has been up for about 17 seconds. Again, we can do this, if we do this command set CLI logical system R1, it changes us to the R1 command prompt, so it's like we're sitting right at R1. So again, that same command is just show BGP summary. And we can see that we've been up for almost 1 minute. However, if I do a show route on R1, you can see that all we have are local and direct routes in our routing table. So we're not learning anything via BGP yet. And this brings us to our first topic when we are talking about routing policies. What I'm going to show you is that in Juniper you use routing policies for a lot of things. Specifically in this example, we're going to use a routing policy to inject routes into and advertise them into BGP. So on R1 and R2, to get our directly connected interface, our loopback 0 interface, to advertise its networks into BGP, we're going to have to create a simple routing policy to do this. And then once we inject these routes into BGP, I'm going to show you how to create an import routing policy and show you how to match a couple of different options. Then we're going to do some show commands for verification at the end. So the first thing that we're going to do with routing policies is on R1. Let's go into configuration mode. And what we're going to do on R1 is we want to get our loopback, advertise our loopback into BGP, get those subnets into BGP so that R2 can see those. To create a simple routing policy, we're going to go under the Edit Then we have the option for policy options, and we see this is routing policy option configuration. So we'll do edit policy options, and then policy statement. So if I do policy options and then space question mark, you see that we have what's called a policy statement, and this is the routing policy. So this is where we're going to do most of our configuration. So edit policy options, policy statement. And then you see if we just try to hit return there, it gives us an error. So if we do a space question mark, you see that we're going to have to name our routing policy. So what we're going to do is we're just going to name this policy BGP export on R1. So rightfully so, the reason we're going to name it BGP export is because with this routing policy we're going to export our loopback 0 interface into BGP. So once I hit enter, you can see that it takes us under the edit policy options, policy statement, BGP export. And from here, this is where we're going to create our simple routing policy. From R1's perspective, what we're going to do is we're going to go ahead and like I was saying earlier, what we're going to do with this, we have four things that we need to do. We need to name our routing policy, which we did. It's called BGP export. So the second thing we're going to do is we're going to create our terms. And we need to know that terms help us in a lot of things with routing policies. If we don't create terms by default, then we're going to run into problems later on where we're going to have to create what's called policy chains. Because if we do not create terms within a routing policy, there can only be one match and one action per routing policy. So the terms gives us the flexibility to add multiple match and actions to a routing policy without having to create multiple routing policies together. So the term is going to really help us out because each term, like I just said, can contain a match action. So let's go ahead and create our first term. We're going to do this with the set command. So we'll do the command set term, and then we're just going to name it T1 for term 1. And in this term 1, we're going to have to match something, and then we're also going to have an action once we have matched a condition. And again, we're using to match, we're going to use the from statement. So we'll put set term T1 from, and space question mark. You can see that we have a lot of different things that we can match under a routing policy. So the first thing we're going to do is we're going to match, we're going to do from protocol. This is the protocol from which the route was learned, space question mark, and you can see that we have a lot of the routing protocols, and we also have the option of direct, so directly connected routes. So for the simplicity of this lab, we're just going to create a routing policy that's going to match all the directly connected routes on the router. So this should include our loopback and all of its subnets. So we're going to do the command set term T1 from protocol direct and hit enter. And this is our match. So we're going to match all directly connected routes, and now we have our action to take. So we're going to create this with the command set term T1 excuse me, sorry about that. Set term T1, and we're going to use the then option. Then what? And we have our first option is to accept a route. So we're going to use that. We can accept it, we can reject it. Those are probably two of the most commonly used are accepting, rejecting. And we're going to see that we're going to use some of these in our second example later on. But for this one, we're just going to we just want to advertise our loopback subnets into BGP. So we're going to do the command set term T1 then accept. So now when under the BGP export routing policy, if I do a show statement, you can see that we have the term T1, where we have from protocol direct, so everything directly connected that matches, we're going to take the action of accepting. So this is a very basic routing policy, and this is what we're going to have to do to export these directly connected routes into BGP. Let's go ahead and commit this. And there's one more option we have to do to actually export these routes into BGP, and that's, if you haven't figured it out, we're going to have to go under our BGP group and export this routing policy into it. So let's go back to the top of our configuration, and then we'll drill down into our edit protocols BGP and then our group. Let's see, our BGP group is going to be 2R2. So we'll go under that configuration. If I do a show statement from here, you can see that I have my options that I set up earlier, which was to name the type text, internal, pure autonomous system, and our neighbor statement. So I'm going to use the set command followed with the export option. So we have set export, and this is where we're going to match an export policy. So set export space question mark. Let's go ahead and go up to where we have our export, our BGP export. Let's go ahead and highlight that, paste that in, and hit enter. So now if I do a show statement, you can see that our export policy we have added is the BGP export. And under the BGP export, let's see. Oh, sorry about that. Let's do this. Under our BGP export, if I do a show statement, under our BGP export we have one term, which is called term T1, from protocol direct. So everything directly connected we're going to accept. And we can see that we applied this under our BGP group as an export policy. So export BGP export. So that's it. That should be all that we need from R1's perspective to advertise these routes into BGP and then send them over to router 2. A quick way we can do this without having to go from R1 to R2 is if I do the command show route advertise protocol BGP and then our BGP neighbor IP, which is 12.12.12.2. And you can see that we have the 1 network, the 11 network, and the 111 network, and also the directly connected to 12 network that we're advertising over. So let's go ahead on to, if I go to, let's see, set CLI logical system R2, if I do a show route now from router 2's perspective, you can see that I'm learning the 111 network, the 11 network, and the 1 network via BGP. So we have these routes now in the routing table on R2. So it appears as though our simple routing policy to export directly connected networks or directly connected interfaces into BGP has been successful. Because on R2 we are now seeing the 1 network, the 11 network, and the 111 network in the routing table. However, on router 2, if I do a show route advertise protocol BGP and then our neighbor statement to R1, you can see that I am not advertising anything to router 1 yet. And that is because, if you haven't guessed yet, we have no routing policy on R2 that's exporting any routes into BGP. So the next thing we're going to do from router 2's point of view is we're going to create an export policy to do so. So again, the first thing we're going to do is set policy options, or you can go under that configuration mode. We're just going to do this. We're just going to do set policy options, policy statement. We're going to call it again BGP export. Again, we're going to have a term that we're going to call T1. And a term is similar to, I guess you could think of it like in a route map on a Cisco iOS device. It's kind of like having your sequence numbers, like sequence 10, 20, 30. Same kind of concept. So we have term T1 from, and this is where we're going to have a match option. So we're going to match from protocol direct. And once we have matched this within the same term T1, we're then going to set our action to accept. Once this is all done on R2, we need to go under protocols BGP for our group 2R1, and then we're going to set our export policy. So export. Then we're just going to export the routing policy that we just created, which is rightfully named BGP export. And that should be it. So now if I do a show on R2 under configuration mode, you can see that we created a simple routing policy called BGP export with one term, which is T1, to match all directly connected routes and then accept. Once we have our simple routing policy created on R2, we then went under the BGP group 2R1 and set up our export option to export this routing policy into BGP. So let's go ahead and commit this on R2. We'll go ahead and exit. We'll do the command like we did before, show route advertised protocol BGP 12.12.12.1, and this is where we can see all the routes that we're advertising to router 1. And now we can see that we have the 22 network and the 222 network. Doesn't look like we have the 2 network. Let's look, and it looks like under loopback 0 somehow our 2 network has disappeared. So it might have been when I did the configuration real fast on R2, I might have skipped over that. Let's go ahead and create that real fast. So we'll do set interfaces loopback 0 unit 2 family inet, and then we'll just put the address 2.2.2.2/24. So I apologize about that if you saw that earlier, that I didn't add that correctly. Sorry about that. So now if we look and see what we're advertising to R1, it looks like we're advertising all 3 of our loopbacks now, which is good, and also the 12 network. So we should be good to go. If I go under R1 and do a show route, now it appears as though all the 2 networks are being advertised into our routing table via BGP. We have the 2 network, the 22 network, and the 222 network. And if we just want to do a simple ping test, we can ping these just to make sure we have reachability to the 2 network, the 22 network, and also, last but not least, the 222 network. And we're good to go. So that's the basic routing policy, where we exported routes from directly connected interfaces into BGP. we verified that they were being learned on the neighboring router. And so our next step in this lab is that I'm going to show you how to create an import routing policy. Or we're just going to create a routing policy, and then we're going to import it into BGP and manipulate some values. So what we're going to look at is we're going to look at using a route filter to deny traffic from a particular subnet. We're also going to take a look at how to tag a route and also how to set the local preference. So again, I'm not really going to go over why you would tag a route or how you would use local preference or how you would use a route filter. I might explain just a little the basics, but for this lab we're just going to show you how you can set these options within a routing policy. So in R1, let's go under configuration mode. If I do a show command, you can see that I have the policy option, the routing policy called BGP export. What we're going to do now on R1 is we're going to create another routing policy. Let's go ahead and do that. We'll go under edit policy options, policy statement, and then we're going to name it from R2. And rightfully so, what we're going to be matching in this is the BGP routes that we're learning from R2. We're going to go ahead and manipulate these routes. And in this routing policy we're going to have multiple terms. The first term we're going to name, or we're going to set term T1. And what we're going to do first is set something to match. And in this case, like I was telling you earlier, we're going to use the route filter option, and this is the list of routes to match. So route filters are commonly used within routing policies, and you can also use prefix lists. So route filters are a little more, I wouldn't say better, but you can use route filters to match more than one prefix. So prefix lists are good because you can match just one subnet exactly, where route filters you can do a match on a /8 or /0 all the way to a /32. So they really give you a lot more flexibility to match a lot more subnets. However, I'm going to show you how to use route filters and prefix lists in a different lab. So I just wanted to tell you that, just in case you're wondering. Route filters, prefix lists are used differently. Route filter is also referred to as a route list, as we can see in the naming. It says a list of routes to match. So that's what we're going to use in this video. We're going to use a route filter. So I'm going to do the command set term T1 from route filter, and you can see that we have a lot of options. First, our address, we can match exactly, we can match longer or longer, through, up to. So we have a lot of options with a route filter, and that's why they are used more than a prefix list. But in this lab, what we're going to do is we're going to match the 22 network, and what we're going to do is, in this routing policy, these routes coming into router 1, the 22 network, we're going to deny it to come into router 1's routing table. So we're going to reject this route in our routing policy. So we're going to do the command set term T1 from route filter, and then we're going to put in the 22 network exactly. again, 22.22.22.0/24 space, and this is going to be an exact match with the prefix length. Or we could put or longer, so it could be a /24 all the way up to a /32. Anyway, I don't want to get too much into that because I don't want to confuse you guys too much. I mean, I don't really want to confuse you at all, but the /24 is what we're going to use. We're going to exact match, so that means that on R2, if we had a /25 instead of a /24 and we were advertising that in, this would not be a match. So we're only going to match exactly /24. So only if router 2 is sending a /24 will this term create a match, and that's exactly what we're going to do. So set term T1 from route filter 22.22.22.0/24 exact. Once this prefix is matched, we're going to then have our action, which is going to be to reject this route. So now if I do a show command, you can see that we have our first term, which is T1, where we match the 22 network exactly with the /24, and then we're going to reject this. Moving right along, our second term, again this is going to be a multi-term routing policy. Our second term, we're going to match the 222 network exactly again, and then we're going to set the local preference value. So we're going to do set term and then T2 from route filter. We're going to match the 222 network /24 exactly. Once we match the 22 network, we're going to create our action, which is going to be used with the then. So set then space question mark, and what we're going to use is the local preference. So we're going to set the local preference associated with this route. Local preference is used with internal BGP to calculate best path through the network for a particular route. We're not really going to explain all of the local preference or how it is a BGP attribute in this lab. We're just going to show you how you can set different things within a routing policy. So again, we're going to use the command set then local preference, and we're going to add, or we're going to give the local preference for this route. Since it is the 222 network, we're going to give it a local preference value of 222. And then our last term within our routing policy, we're going to name set term T3. And then what we're going to do in this statement is everything else we're then going to give it, if I do a then space question mark, see we have an option for a tag where we can tag a route. So we're going to tag this route, and we'll just give it a really awkward tag value so we can see this easily within the route. Oops, that was a little too big. Sorry about that. So we're going to give it a tag of, let's see, what is that? 222,222,222. Again, I'm not really going to explain why you would use a tag, but sometimes you want to tag routes as it comes into a routing protocol so that you can either accept it or drop it. Again, that has more to do with route redistribution, which is a little more complicated of a topic to discuss in this lab. So if we do a show statement, we see that we have within our routing policy from R2 we have three terms: term T1, term T2, and term T3. let's do this. For some reason, it appears as though our routing policy got a little messed up. Let's do this. Set. For some reason I have set then. I should have said set term. Let's do this. Sorry about that. It's always good to look at your stuff here. Let's do set term T2, then local preference 222. Oh, let's go ahead and look at a show. Let's see, we have, that's right. Let's do this. Set term T1, then reject. So we'll do the command delete, then reject, and delete. Local preference, let's see. Let's do this. Alright, sorry about that. Just had to, I just saw that I placed those actions under the first term, and so they wouldn't have, let's see, actually those actions were set incorrectly. So I apologize for that. So now it appears as though we have our actions under our correct terms. So term 1, T1, we're going to be matching the 22 network, and we're going to reject it. Term 2, again we use a route filter to match the 222 network. Once this network is matched exactly, we're going to then set the local preference to 222. And our last term, which is term 3, everything else, we are going to give a tag of 222,222,222. So what I did wrong was I did not specify with my set commands the action under the correct term. So that I just went back and did that to make it correct. So if you were wondering what I was doing earlier, I apologize. I put my set commands under the wrong terms. So now they're all correct. Let's go ahead and commit this on R1. And I'll just show you real fast. You can see under term T1 above, I just had from route filter with no action. Also, I had the same thing for term T2. I had from route filter but no action. Then I just had under, not under any term, I had then local preference and reject. So that was a bad mistake. I forgot to put the local preference under the term T2 for the action, and I also forgot to put the reject option under term T1 for the action. So I went back and modified that to make it all correct, and I just committed the changes. So now on R1, if I go back to operational mode, let's go ahead and take a look at our routing table and see what we have. Right now it looks like we still have the one network, the 2 network, the 22 network, and the 222 network. And this is because, just like we did when we exported routes into BGP, we have to, once we have the routing policy created, we actually have to apply this policy under our BGP group as an import policy. for this to take effect. Let's go under configuration mode. We'll go under edit protocols BGP, and then for group and in this option we're going to have 2 R2. So under our BGP group on R1 we're going to do the command set, and then instead of doing export where we exported routes into BGP, these routes are going to be coming inbound from from R2, from our neighbor R2. So we're going to apply this as an import policy. So we're going to do set import, and then it's going to ask us for our import policy name. And our import policy name is going to be from R2. Let's go ahead and commit and quit. Let's go ahead and now do a show route, and the first thing we can see in our routing table is that the 22 network is gone. And that is rightfully so, because in our routing policy, once it matched our term T1, I believe that was. Let's do this show configuration. Our term T1 was that the 22 network was to be rejected once it matched. And on R1, if I do a show route, you can see that is exactly what has happened. The 22 network is now not in the routing table. Also, what we can see just by doing a show route is that the 222 network has a local preference of 222. Again, the default local preference value in BGP is 100. So we set that local preference value on R1 for the routes from R2, the 222 network, to have a local preference of 222. And we can see that that is indeed happening. And our last option, which was under term T3, was for everything else that did not match the term T1 or term T2 above was going to be matched in term T3, and that is exactly what happens when you don't have a from statement that is matching anything. It's going to, if we just have a then statement or an action, everything is going to match this by default. And we put a tag on everything that all the subnets that are not matched on term T1 or T2. So if I do a show route on the 2 network, let's do this show route detail, we can see that in the show route detail on the 2.2.2.2 network, we can see that the tag of 222,222,222 is being applied. Let me show you one last thing. If I do a show route receipt protocol BGP from our neighbor, which is router 2, so 12.12.12.2, we can see that we are receiving the 2 network and the 222 network. If I do a command show route receipt protocol BGP hidden, it's going to show us the prefix that was actually being filtered by the local router. This filtering that's taking place is that this 22 network is being denied. So if I try to ping the 22 network, obviously this is not going to work. However, if I try to ping the 2 network, it works just fine and is reachable. Also, you can view this hidden route. If I do a show route hidden, you can see that the 22 network shows up there as well. So that's it. That's the Juniper Routing Policy Lab 1. I just showed you how to set up basic routing policy. First thing we looked at is how to export a or to create a routing policy to export our directly connected interfaces into BGP and advertise them to our neighbor. Then we looked a little bit more at routing policy from router 1's point of view. We created an import routing policy to import into BGP on R1. We looked at a few values. Let's go back to router 1, do a show configuration, policy options. We created the routing policy called called from R2. We had, in this one, was a multi-term policy where we had 3 terms. We had term T1 where we matched the 22 network exactly and rejected this route from being added into the routing table. And we showed you the proof that that was exactly what was happening after we applied this. We had the term T2, which matched the 222 network exactly. We set the local preference value to 222, and then we had the term T3, which matched all other routes being learned from R2, which was the 2 network, and it applied a tag of 222,222,222 to that route. The last thing that we had to do was to do on R1. We went under the group configuration to router 2 and applied this import routing policy, which was called from R2. Once we did that, we verified that all of these terms within the routing policy were indeed working correctly. So again, this is Juniper Routing Policy Lab 1. Thanks for watching, and I hope to see you in the next one.